Okay, part 3 then wants the part of the Cartesian equation of the curve. So we've got this y equals sine t sine 2t, and we've also got x equals 1 minus cos t. Normally on these types of questions, if parametric equations involve trig, we usually say try squaring each one and adding them together, so that we can use somehow cos squared plus sine squared equals 1. That doesn't work quite so well on this one. But what we do have is this sine 2t term here, and we can immediately change that to 2 sine t cos t. So if I swap this for 2 sine t cos t, and we've still got that other sine t at the front there, that we can simplify to 2 sine squared t cos t. We can change this cos t into, well, if we write cos t over here and add the cos t to that side and take away the x, we've got that cos t equals 1 minus x. So we can change cos t for 1 minus x quite easily, and that's going to be helpful because that's starting to introduce the x variable into the y equation, which is what we're after for Cartesian form. But now this sine squared t is going to be a bit of a problem. But now what we can do is write down what cos squared t is. Cos squared t is going to be 1 minus x all squared. So if we expand that, we're going to get 1 minus 2x plus x squared. But that's also 1 minus sine squared t, because cos squared plus sine squared equals 1. So if you notice here, we've got a plus 1 term on each side, so we can just get rid of them. And therefore sine squared t, which is what we're actually after, is equal to positive 2x take away x squared. So we can sub that in as well. So we're going to get that y is equal to 2x minus x squared times 1 minus x. That's actually a polynomial in terms of x. So technically we should be allowed to stop here. I'm not too sure if we can. I've not seen the mark scheme yet. So just in case, I'm going to write this in a few different forms. One form that we can write it in is we can write it in factorised form. It's going to be really easy to factorise this polynomial because it's already partly factorised. You can see that there's an x term in here. We could write that as x times by 2 minus x. So if we take the x out, that will join up with this 2 here. So we've got 2x bracket x minus, 2 bracket 1 minus 2x bracket 2 minus x. And because these are both 2 minus x terms, we can take the minus out of both, the minus factor out of both of these and write them the usual way that we would see them. So the reason I can do that is because I'm taking out a factor of minus 1 from here and minus 1 from here. So I don't need to put a minus here because minus 1 times minus 1 is positive 1. So this is the fully factorised form of our polynomial. We could expand the brackets fully, and if we did that, we would get 2x squared take away 3x plus 2. And if we included the 2x in that, we would get 2x cubed take away 6x squared, 2x cubed take away 6x squared plus 4x. So I reckon we'd be allowed to stop here, but just in case, it might be worth going all the way to the end just to double sure that you get all the marks that you deserve.